Good day, everyone. My name is Chris Romel Ramos, and today I will be presenting to you a couple of satellites. Which the first one we will be discussing an active satellite. Then later on we will be discussing another satellite, which is a decommissioned one. Starting with our presentation, as mentioned a while ago, the first satellite is currently operational. We call it the Navstar 78. Navstar 78 is a NEO satellite. And with its the mission focus is basically about navigation and position improvement and timing services for the warfighter and civil users worldwide, and thus provide advanced anti-jam capabilities yielding for superior system security, accuracy, and reliability. The launch date of Navstar 78 was August 22, 2019, and this was launched through the vehicle of Delta V, as you can see here in our presentation. No? And the launch site, or the location where it was launched before, it was the Air Force Eastern Test Range, which is located basically at the Cape Canaveral, United States. The mission payload of the Navstar satellites is the navigation subsystem. For all we know, as mentioned a while ago, Navstar 78 is one of those Navstar satellites which is in trust or commissioned, or basically its mission was to improve the navigation system basically. And the mission payload basically consists of the frequency standards. Having a three rubidium atomic standards are provided. They are used in dormant redundancy configuration and are selected by ground command. Another payload which was tasked for this Navstar satellite was the processor baseband, as it generates pseudo random codes and modulates them with the digital data. And it is internally doubly redundant, and sections can be switched by command. So the applications basically is comprised or basically is focused on navigation. And another one would be the RF equipment itself, consisting of carrier frequency synthesizers, modulator, intermediate power amplifiers, or the IF amplifiers, and high power amplifiers. The two L-band carriers are combined in a diplexer filter, which in turn feeds the shape beam antenna. The RF equipment is totally redundant and individually switchable except for the diplexer and the antenna itself. We can also see here the bus, or basically the subsystem, consists of the following. We as mentioned a while ago, we have the RF section, we have the antenna, we have the frequency standard, the digital section, the processor hardware, and its firmware. The subsystem in details, we can see that are under its RF subsection RF section. The signals were derived from the 10.23 megahertz output of the frequency standard. Two L-band carriers denoted L1 and L2 are synthesized from the standard frequency. And another one thing, and the details under the antenna. The intent of the antenna, obviously, is to provide equal power density to all terrestrial users. This is very important, especially particular with the mission of Navstar is for the navigation purpose. So the antenna plays a vital role, should we say, no, for this satellite. This is accomplished with a shape beam antenna, a quad helix encircled by a ring of eight helices, and the frequency standard considered as the heart of the navigation system, or the navigation subsystem itself, as this is the source of the GPS ranging function. As we said a while ago, the purpose of Navstar 78, or should we say the Navstar satellites, even the other Navstar satellites, no, is for the GPS capabilities. So it is one of the tasks basically, since this is a task to improve the navigations, no. They further develop the GPS ranging functions. The frequency standard short-term and long-term stability characteristics and predictability determine the basic navigation accuracy that can be achieved through the GPS or through by the global positioning system. Okay? Under the digital section of Navstar 78, this consists of a processor baseband assembly, which includes three processors, each assembled on a two-sided circuit board, and three sets of baseband electronics, each assembled on the two boards itself. The processor hardware consists of a PPS4 microprocessor augmented by an ALU or an arithmetic logic unit with interrupt capability. The ALU and its RAM or the random access memory used as a buffer or scratch pad, which provides the upload interface with a 1000 bit per second SGLS and S-band command link. And to ensure the processor firmware, the navigation processor program uses a combination of an interrupt driven logic and polled discrete and flags to initiate the task, which must be performed on a continuous basis. When power is applied to the processor, it goes into its bootstrap routine, which initializes the processor memory, and to state the readiness of the initialization of all other routines as the interrupt discretes or the flags are set, basically. So that's about the Navstar 78. As mentioned a while ago, during the beginning of my report, I will be discussing another satellite. This time, this will be a decommissioned one, or should we say that the mission was all already finished or done. And we there are lots of decommissioned satellites, as we can see. If you're going to search the internet, we have a lots of lists of decommissioned, or we can say a retired. Satellites, which is amazingly, which is amazing because even it was already decommissioned, no? Those satellites still perform very well. What I'm trying to say is that the function basically exceeds its design, no? And one of those is this one is the Genesis One. Genesis One basically is an American entrepreneur's inflatable satellite. This is a very popular decommissioned satellite back then, no? Launched by the DNEPR rocket from a converted ICBM missile site in southern Ural Mountains. The 1,300 kilogram craft, or the weight basically of the Genesis One, was successfully inflated about 2 hours after its launch to its normal cylindrical size, having a size of 2.4 by 4.5 meters basically, or approximately a typical size of a garage, no? It is made of a tough sheet of fabricated from a composite Kevlar. As we have said a while ago, this is an inflatable type of satellite, no? That's why it's made of a composite Kevlar that is often used for bulletproof vest. The goal of the entrepreneur, or the owner, is to launch a few more of them, string them together, and promote space tourism. No, so one of the initial, or should we say, initial intention, should we say, of the Genesis series was for the space tourism. No, and as we can see, this was launched way back in 2006. And the launch site was in the Yasny, or Yani. I hope I got it right, in Russia, located in Russia. The payload of the Genesis One, actually there are a total of 8 payloads making up the 4 science instruments on Genesis. Number one, as we have mentioned ago, this is for space tourism, no? And they have 8 payloads. One of them are the 3 specialized collector arrays. Each collector was assigned to catch various types of solar wind and to collect billions of atoms of solar particles heavier than hydrogen, equivalent to a few grains of salt. So it is very obvious, since this is practicing, should I say, space tourism. One of its intent is to catch those types of criteria, as we can say, samples, no, of the atmosphere. No, another one we have here the two bulk collector arrays, a solar wind collector mixing influences from all three types of wind regimes. And we have the concentrator. This is designed to concentrate the heavy ion flux from the solar wind by an average factor and implant it into a target of ultra pure, well characterized materials. We all know during the study of these satellites, no, the atmosphere basically in space is very different compared with the typical atmosphere that we are calling right here basically on earth, no, the behavior, the characteristics, the media, or anything that we are that can be encountered in space is totally different as compared to earth, no. So basically these payloads under the genesis is very important, no. And another one we have here, the ion and electron monitors. So basically, obviously, we need those monitors. The primary purpose of these spectrometers is to enable the collection of appropriate samples of the solar wind. While the secondary function is to obtain highest quality solar wind data that can be used for various scientific studies, no. So during those we as we can say they have this tour, no, this space tour, no. It is very important that during those tour or during those orbits conducted by Genesis, they need a lot of data for them to study, no, for future references for other to those who are engaging basically in space activities, no. And pertaining to the bus of Genesis 1, as we can see here with under the diagram, there are lots of basically compositions when it comes to the bus of the Genesis 1. But basically, I will discuss which I find it important. No, some of the subsystems of Genesis 1. So this one here in bullets are not the total subsystem basically as Genesis 1 as mentioned a while ago. I will just be briefly discussing those who are for me I find it important, no? The sample return capsule, obviously, since this space unit is collecting different samples or for them to study, it needs obviously a return capsule, no. So that's why I put it first on the list. We have here the sample return capsule, the flight software, the telecommunications basically for communications purposes, the electronic power, the propulsion for it itself to navigate, no, the guidance navigation and its control, no. Under the Genesis subsystem, the sample return capsule is a blunt nose cone with a diameter of 152 centimeters or around 60 inches. So 160 inches, that would be around a couple of feet, should we say, or more than, I'm sorry, that would be around 5 feet. No, it has five major components: a heat shield, back shell, sample return canister itself, the parachute system for braking purposes. I don't know in particularly what's the exact purpose of the parachute system, but I believe this is for the braking system whenever it starts to penetrate the atmosphere, no? And avionics itself, no, the flight software. This is very important. Genesis receives its command and sequences from Earth and translates them into spacecraft actions. The flight software is capable of running multiple concurrent sequences as well as executing immediate commands as they are received. And also, I mentioned a while ago for the communications, under the telecommunications, the Genesis telecommunication subsystems is composed of both radio system operating in the S-band under the microwave frequency range, no? And a system that operates in a ultra high frequency range or the UHF range, no? The S-band system provides communication capability between Earth and the spacecraft throughout all phases of the mission. The UHF system is located in the sample return capsule itself. After parafoil deployment, it provides a backup tracking capability. So one of the very obvious reasons when the sample return capsule needs to go back to the Earth's atmosphere, or basically on Earth, no, it needs to be tracked, no. So we can say that the sample return capsule itself already also have its own telecommunications systems, no. Another thing we have here, basically, this is one of the basic, but we can say another important subsystem or factor when it comes to satellites. No, we have this electronic power. Electronic power. The system obtains its power from an array of standard silicon solar cells arranged on two panels in either side of the equipment deck. It is this one. This is very popular now. Whenever we a typical satellite equipment or a satellite device that we could see, whether in television or whether in even in the internet, we can see those wings connected on the instrument or the equipment itself. Those are the solar cells, no, or the panels. The two solar panels, considered as wings, as I mentioned a while ago, made of silicon and aluminum, are fixed in place and hold grids of silicon cells, which generate 265 watts at Earth's distance from the sun. So it is very important since this is on its own, no. It basically needs to have its own power, no. So the electronic power should be reliable enough for the equipment or the satellite itself to perform its duty, no. The propulsion subsystem features sets of two kinds of small thrusters. The larger are used to make major trajectory correction maneuvers, and the smaller ones are the ones to continually maintain the aircraft spacecraft in its orbit. I'm sorry, in its orbit. Now it is very obvious that whenever we're trying to navigate the satellite, no, the propulsion system plays a vital role because without this, together with the other equipments, obviously, or with the other features of the satellite, the satellite itself won't be able to maintain its orbit, no, its distance, its speed, the directions, or particularly to maintain its mission, no. And lastly, we have here the guidance, navigation, and control. Genesis maintains its orientation, or we call it the attitude, by continuously spinning around in space. The attitude control system will keep Genesis spinning at a rate of 1.6 revolutions per minute. Genesis determines its orientation at any given time using a star tracker and sun sensors. So that's a very quick, short presentation of mine about two satellites. No, the first one is the Navstar 78, as mentioned a while ago, the Navstar 78, and then the other, which is currently still working or operational. And lastly, we have the Genesis one, or another decommissioned satellite. No, that's. I hope you learned something about my report and my presentation. And that will be all. Good afternoon, everybody.